Hello students, I am Hemant Lagwankar. Now today in this video lecture we are going to study one new interesting topic. Now this video lecture I am going to start with an activity. This activity you can do at your home. It's very interesting but simple activity. I think many of you might have done this activity before. Let us see the activity first. Here we have taken some paper pieces on table. Tiny paper pieces, and you have to spread those paper pieces on table. And then what you have to do? You have to take plastic comb or plastic scale which is there in your compass box. And you have to rub the comb on your dry hair and bring that comb near this. See what you observe. When you rub this comb on dry hair and bring to the paper pieces, you will find they are getting attracted to the comb. They stick to the comb. See now. Now, why this happens? This is happening because of static electricity. When you rub comb or plastic scale against dry hair, because of friction, the electric charge is deposited on that plastic object. And because of that electric charge, the paper pieces get attracted towards that comb or plastic scale. Now, what do you mean by electric charge? How they are developed on plastic objects like this? And what are the properties of these electric charges? All these things we are going to study in the video lecture. Also, we are going to study its analogy with magnetic poles. So, let us start with electric charges. Now, how these electric charges are produced on the object? We know that every object is made up of atoms. Now in an atom there is positively charged nucleus at the center, and around this nucleus there are negatively charged electrons revolving around different orbits. Now atom as a whole is neutral because there are equal positive and negative charges in an atom. So atom is electrically neutral. There is no electric charge on atom. But now what will happen if you rub the objects? Let us see that. We have taken here the glass rod and a silk cloth. Now we will rub this glass rod with a silk cloth. So we are rubbing it, and after rubbing this, what you will find? The electrons on the glass rod, they get transferred on the silk cloth. See, the electrons are getting transferred. Obviously, the silk cloth becomes negatively charged and there is positive charge developed on the glass rod. Here you can see in the clip what is happening. When you rub such glass rod, and if you bring this glass rod near the fibers, they get scattered. So what is happening here? See, the glass rod becomes positively charged and silk cloth becomes negatively charged. Remember here, the charges are not produced. Due to friction, because we are rubbing that glass rod against silk cloth, because of the friction, the electrons from the glass rod, they are getting transferred on the silk cloth. And since electrons are being transferred, the glass rod becomes positively charged and silk cloth becomes negatively charged. So, friction is the cause to have the object charged. Again, I am emphasizing the point that we are not producing any charges. But just by rubbing the objects against each other, we are making them charged. So that is how the charges are developed on the objects. Of course, the charges which are developed on the object, they remain on the surface of the object. They remain steady on the surface of object. That is the property. And that is why we call it as static electricity. Static means something which is at rest, which is not moving. So what we have seen? We have seen there are two types of charges. One is positive and the other one is negative. Now let us consider one important property of these charges. Again, what we have taken a glass rod and it is suspended with some rigid support. Now we are just rubbing that glass rod with silk cloth, so it becomes charged. Now we have taken another glass rod, say CD. Again it is rubbed against silk cloth, so it is charged, and now we are bringing it towards AB. And you have observed. What you have observed? This suspended glass rod is getting deflected. The end A of this suspended glass rod is getting repelled because of this another glass rod CD, which is again charged. So there is a repulsion between the two glass rods. Now the next step of experiment is, instead of glass rod we have to take plastic rod, and we will carry out the same experiment again by using plastic rod. Let us see that. So we have taken the plastic rod EF and it is rubbed now against woolen cloth. So this is woolen cloth and plastic rod is rubbed against it. So again it becomes charged, and now we are bringing it closer. Now what you have observed? You have observed that end A of rod AB is getting attracted towards this plastic rod. So this time there is attraction. Previously we have seen there was repulsion and now there is attraction. So in one case there is repulsion and in other case there is attraction. Now how is it possible? What is the cause of these two results? What is the analysis of these observations? Let us see that. So there are two charges, positive and negative. Now we will take two like charges. What do you mean by this? Let us see. See here, we have taken like electric charges. Like means they are of same nature. So here we have taken two positive charges, or you can take two negative charges. So these are the like charges. These are also a set of like charges. Now if such like charges are brought closer, what you will observe? They get repelled. They are moving away from each other. So there is force of repulsion between two like electric charges. That is what we observe. Now instead of like charges, if we have taken unlike charges. So here we have taken unlike electric charges. What is the meaning of unlike? Unlike meaning the charges are of different nature. So one is positive and the other one is negative. Now if we bring such unlike charges closer to each other, what you will find? You will find that they are getting attracted towards each other. So they are coming closer. So what we have learned from this? We have learned that if we have taken two like electric charges, meaning either they are positive or they can be negative. If we bring such two like electric charges together, they repel each other. They move away from each other. And if we take two unlike electric charges, that means one is positive and the other one is negative. If we bring those unlike electric charges together, they attract each other. So they experience attractive forces between each other. So that is the property of electric charges. Now, scientists tried to detect these charges, and for that they developed some instruments. Very primitive instrument for detecting electric charge is gold leaf electroscope. What is that gold leaf electroscope? Let us see in the picture. See, here we are seeing gold leaf electroscope, and it was first prepared by Abraham Bennett in 1787. Now, how we can detect the electric charges by using gold leaf electroscope? Let us see that. Here we are seeing one glass jar. It is closed with a lid, and a rod, which is metallic rod, brass rod, is introduced in the glass jar. At one end of the glass jar there is a disc. The disc is at the end, which is outside the glass jar, and inside there are two leaves. You can see leaves means there are foils, and these foils are of gold. So two gold leaves are there at other end of the metallic rod, which is inside the jar. Of course, you know that the gold is precious metal. It is costly. So we can use in fact aluminium leaves instead of gold leaves. You can prepare even electroscope in your home also. See, here is electroscope. We can prepare like this. You can take, say, plastic bottle even, and in that you introduce one copper wire and you attach the two very thin foils of aluminium, and these will serve as leaves. Now, how it works? Let us see that. So this is the gold leaf electroscope. Here all these parts are shown, which I have explained to you, and this is the glass rod we have taken. We will rub this glass rod against a silk cloth, and now we will bring that glass rod close to this brass or metal disc. Let us see that. Now see, it is brought close to it, and when we brought this charged glass rod close to it, or if we touch this even, then you will find that the leaves are moving away from each other. And why they are moving away from each other? Because like charges are developed on each of the leaves and they are getting repelled. So they are moving away from each other. So if you find that they are moving away from each other, obviously you can say that this object is charged object. If the object is not charged, obviously there will not be any deflection observed in case of these leaves. Let us see the video clipping again and we will observe how it actually looks like. Now the rod is brought close to the disc and you will see the leaves are moving away. See. Now friends, the familiar example of this electrostatic charges or the electric charges is the lightning in the sky. Now when air currents flow with tremendous velocity through black clouds containing water vapor, they cause friction between tiny water droplets. And due to the friction, large amount of electric charges are developed on the clouds. These electrically charged clouds move from one place to another due to flow of air, and when two clouds of oppositely charged come close to each other, electric spark is generated between those two clouds and we see lightning. A large electric potential difference between two clouds or between cloud and earth's surface causes lightning to occur. Now when lightning strikes the earth's surface, it moves through the shortest distance between the cloud and the earth's surface. Hence, lightning most probably strikes on tall buildings, hills, or say trees, etc. And we know that this lightning is dangerous because it may cause damage to the properties. Not only that, it may take lives even. So we must protect ourselves and our properties from this lightning. Let us see how we can do that. Now here you are seeing one illustration. What is that? There is a building here, and on the roof of this building there is a copper strip, long copper strip, and that copper strip has a pointed edge, or there is a point, or it is a fork kind of strip. Now this strip is connected to a thick copper wire. This is the wire, and it goes directly into the ground, and in the ground it is connected to a thick plate of cast iron. So this particular copper wire and copper strip provides the path for the lightning to go directly to the ground. So when lightning strikes like this, it goes through this copper plate and through this copper wire directly to the ground, and it won't fall on the building or say roof of this house, and it will avoid damage. So this particular arrangement is done to protect from the lightning strikes, and it is called as lightning conductor. So friends, what we have seen, we have talked about electric charges. They are of two types. One is positive, other one is negative. And we have also seen that two like charges repel each other, while two unlike electric charges attract each other. We have also seen how lightning takes place and how electricity or electric charges are involved in it. Now, analogously, we can talk about magnetic poles or the magnets. Now remember, we have started this video lecture with an activity, and in that activity we brought the rubbed comb or plastic scale against dry hair near to the paper pieces. Similar activity we can carry out with the magnet, and let us see that. What is that activity? So we have taken a magnet and we have some pins, iron pins. Now if we bring this bar magnet close to the pins, what will happen? Let us see that. The pins get stuck to the magnet. So there is attraction between the magnet and the pins. Remember again, we have also seen how paper pieces get attracted towards the plastic comb or plastic scale. Now what is happening here? Here we know that the magnet applies or exert force on magnetic materials such as iron pins, and these magnetic materials get attracted towards the magnet. Now let us imagine that these pins are far away from the magnet. The magnet is at one corner of the room and the pins are kept in another corner of the room. Will you observe such attraction then? Answer is no. To have this kind of attractive force act between them, we need to bring that magnet close to the pins. And at certain minimum distance between them, you will find that the pins are getting attracted towards the magnet. Meaning that there is certain area, certain region in which that influence of magnet is felt. Outside that region, outside that area, the influence of magnet does not felt. So this particular area in which the influence of magnet is felt is called as magnetic field. Similarly, we need to bring that comb close to the paper pieces. If the comb is far away from the paper pieces will not fly and get stuck to the comb. This won't happen. So we need to bring that comb close to the paper pieces. I am I'm just highlighting the analogy between the two activities, remember. So the point is that there is a definite region or area around a magnet in which the effect of magnet is felt, and that region we call it as magnetic field. So magnetic field is around a magnet. Similarly, there is an electric field around the electric charge. So let us talk about this magnetic field in detail, and then you will understand how the electric field also behaves. One more important thing, friends, that these magnetic field or electric field, they are not visible. We cannot see such object or such field around a magnet like an aura. We don't see that. So we have to explain this electric field, and this electric field or magnetic fields, they are explained by means of lines of force. Let us talk about magnetic field first. Now here you are seeing some lines around a magnet. Let us see what are these lines. Now here is the bar magnet. S stands for south pole of the magnet and N stands for north pole of the magnet. And dotted lines are shown. Though they are shown dotted, they are continuous. They are not broken in between. This is a kind of notation, and that is why we have shown by dotted lines. Now these lines are curved. You can see these lines are curved. So these lines we call it as lines of force, and in case of magnet they are called as magnetic lines of force. Now if you observe carefully, there are arrows. Small arrows are shown, and arrowhead, they are indicating the direction in which the lines of force go. So it is assumed that the lines of force, they originate from north pole of the magnet and they terminate on south pole of the magnet. So that is a kind of convention that we follow. So these are the lines of force. Now you will ask me, can we see these lines of force? Answer is yes. Definitely you can see lines of force, but in some other form, by means of some object. So we will see magnetic lines of force, and you are seeing first of all the picture of one scientist. It is a picture of British scientist Michael Faraday, who introduced the concept of lines of force to explain magnetic and electric fields, or the attraction and repulsion between the two poles of magnet or two electric charges. Now here you can see these lines of force which are introduced by Michael Faraday. Now I am coming to the point that can we see the lines of force. So let us see that. In this picture we are seeing the lines of force. Now what is this? This is the bar magnet. Okay, this is south pole and this is north pole, and these black particles, they are iron filings. So you can see a peculiar pattern of iron filings in this particular picture, and you see that they are curved like this. So by means of iron filings we can see the lines of force. Now can you make this kind of lines of force on your own? Yes, definitely. Let us see an activity. See here what we have taken. We have taken a magnet and a plastic lead is put on it. We can see the magnet below it, and we are sprinkling iron filings on the plastic lead, and you will find that the iron filings are getting arranged in peculiar pattern. See this, see the peculiar pattern. So that is how you can see lines of force. We can explain magnetic attraction and repulsion between the two magnetic poles by means of lines of force. Here there are two magnets we have taken. In the first photograph, it is shown that south pole of one magnet is facing towards north pole of another magnet. And as before, we have sprayed or we have sprinkled iron filings, and you will find peculiar pattern like this. See, the lines are coming closer, or they are moving towards each other. So we can see clearly there is attraction. So there is attraction between two unlike magnetic poles. These are unlike magnetic poles. One is south and the other one is north. Now in the next picture, what we are observing is we have brought two like poles together. These are the two magnets having north poles facing each other, and see now the pattern. The lines of force are going away from each other. See, the two patterns are different. Here we can see repulsion between the two like magnetic poles. Remember, the same thing is true in case of electric lines of force also. Around the electric charge, we can have similar lines of force, and they are called as electric lines of force. So we can also explain the attraction between two unlike electric charges or repulsion between two like electric charges by means of electric lines of force. So there is a perfect analogy, and the lines of force, this particular concept can be used for magnetic poles as well as for static electric charges. So friends, what we have learnt? We have seen so many activities in this video lecture, and many of the activities you can perform at home. These activities help us in understanding the nature of electric and magnetic field. We say that there is a region or there is a field around the electric charges or magnetic poles in which these magnetic poles or electric charges are effective. So they are either electric field or magnetic field. And to explain electric and magnetic field, the concept of lines of force was introduced. We have seen the two like electric charges repel each other and two unlike electric charges attract each other. Same is the case with magnetic poles. Two like magnetic poles repel each other and two unlike magnetic poles attract each other. So there is a perfect analogy, and we have compared the electric charges. There are two types of electric charges, positive and negative, and we have compared these charges with two poles, north and south. These are the two magnetic poles, and we have talked about lines of force. Now friends, there is a task for you. And what is that task? You might have magnets in your home. Just search for them. We use different kinds of magnets in different gadgets. If you look carefully, you will find many magnets in your home also. So with the help of those magnets and iron filings, try to get the magnetic lines of force and observe how magnetic attraction and repulsion takes place with the help of the iron filings. So I hope that you have enjoyed this video lecture, and you will definitely try to carry out these activities in home. Now today we will stop here. Goodbye.